Hi guys, welcome to our channel Shubhada Group of Education. You are watching Satishnieit physics videos for CET and NEET. Look at the next problem on electric potential. Electric charges of 10 microcoulomb, 5 microcoulomb and minus 6 microcoulomb are placed at the corners of a square of side root 2 meter. The potential at the center of the square in volt is correct. See, in such cases what we do is I will draw the free body diagram for this particular problem now. See here, this is the point A and this is the point B and this is the point C and it's a point D here. Okay. Now the 10 microcoulomb is placed here and 5 microcoulomb is placed at point B and minus 6. Okay. Minus 6 microcoulomb is placed here, and the potential at the center is the question right now. So now the question is to find out the value of the potential at the center. Let me take the center as O now. Okay, the side is given as how much? Root 2 meter. Root 2 meter, root 2, root 2, root 2. Okay, see clearly AO must be equal to BO, that must be is equal to CO, that must be is equal to DO. Okay, that is equal to side divided by root 2. Okay, so simple expression, that is what side, so the square side of the square divided by root 2, so that you will get the value of that is the half of the diagonal. Okay, diagonal is AC or BD, correct? Half of that is nothing but side by root 2, so that is what side is root 2 divided by root 2, that is going to be 1 meter. Okay, so therefore the potential at the center O must be equal to VO must be equal to VA plus VB plus VC. Okay, so there is no charge at point D, so that's the reason we will get the electric potential at point O due to A, point O due to B and point O due to C here. Okay, so for that what I do is 1 by 4 pi epsilon naught is common here, 1 by 4 pi epsilon naught is common, and QA divided by side is also common, right? AO plus QB divided by OB plus QC divided by OC. So that is equal to 9 into 10 to the power of 9 into AO equal to BO equal to CO, right? That is what 1 divided by 1 into QA is how much? 10 micro plus 5 micro plus that is what? Minus 6 micro here. Okay, so that will get 9 into 10 to the power of 9 into 15 minus 6 is how much? It is 9 micro, 10 to the power of minus 6 is nothing but 81 into 10 to the power of 3, 81 into 10 to the power of 3, or else 8.1 into 10 to the power of 4 volt is the right answer. 8.1 into 10 to the power of 4, option C or option 3 is the right answer for this particular question. Next one, two small spheres each carrying a charge Q are placed R meter apart and they interact with a force of F. Okay, if one of the sphere is taken around the other once in the circular path, the work done is clearly it is 0, right? Because as you know that F, the force or the displacement, so there's a displacement, right, in the same path. The two small spheres carrying the charge Q here, correct, then the radius R diameter. Suppose if it is two spheres and they are separated at a distance of R now. Okay, so they interact with, so one is positive, one is negative here. This is the force. Okay, that is what the force here, and you know that work done must be is equal to force into displacement, right? Force into displacement, that is what FDS cos theta. FDS cos theta. If one of the sphere is taken around the other in the circular path, the work done is clear. This is nothing but a conservative force, right? So since the force and displacement are perpendicular to each other, that's the reason why this theta is going to be how much? 90 degrees. So then we will get the work done as 0 here. It's a problem based on the equipolar surfaces as well. So there is the if the circular path, so at that time there is no displacement we can say, or else the force and displacement both are perpendicular to one another, so that's the reason why theta is 90 degree. That's the reason work done must be is equal to 0. Next one, the charges plus 8 nanocoulomb and minus 8 nanocoulomb are placed at A and B. P and Q are the points lying on the perpendicular bisector of the line AB. Work done in taking a charge of 5 nanocoulomb from P to Q is. Okay, and even this is also a problem based on the equipotential surfaces, correct? So charges are at point A. So suppose if I take this is point A and this is point B here. At point A that is plus 8 nanocoulomb and at point B it is minus 8 nanocoulomb. Okay, one is like this electric field, one is like this electric field. Okay, so P and Q are the point lying on the perpendicular bisector of the line AB. So this is point P and this is Q. Let me take here. So now this is acting like what? The equipotential surface. This is the line acting like the equipotential surface now. Okay, so the work done in taking a charge 5 nanocoulomb from point P to point Q. Point P to point Q here. So like this. So that's the reason why, as it is in the equipotential surface, that's the reason why the work done is going to be how much? 0. So option 1 is the right answer. At the center of a square ABCD, there is a situated an electric charge of 100 divided by 3 into 10 to the power of minus 9 coulomb. Find the work done in moving a charge of minus 10 by 3 into 10 to the power of minus 9 coulomb from a corner A to corner B of the square when the side of the square is 2 centimeters. The question, correct? So when here, say, so let me use the free body diagram now. Okay, free body diagram. So this is what the free body diagram here. Okay, so square ABCD, and there's an electric charge of, okay, at the center. Let me take it as a center now. Center ABCD and this is the center O. Okay, so now charge of minus 10 by 3 from corner A. Okay, corner A, from corner A, that is what, minus 10 by 3 nanocoulomb from A to point B. Here to here we need to move it, correct? See now, so at that time what is the work done? You know that work done per unit charge is something but potential V. Okay, so for this what we do is, work done in moving a charge from A to B, it is something but the potential difference, potential at point B minus potential at point A into the charge moved. Okay, so at point A as well as point B you will get the electric field due to what? Due to 100 divided by 3 into 10 to the power of minus 9 coulomb, which is placed at the center. Okay, so that's the reason why I will calculate the value of the calculate the potential difference, and the charge mode is 10 divided by minus 10 divided by 3 into 10 to the power of minus 9. Okay, so that is what equal to the work done, that must be equal to 1 by 4 pi epsilon naught is common, right? For VA and VB, that is 1 by 4 pi epsilon, that is what 9 into 10 to the power of 9 is common, into VB. Okay, so here is VB, there is a potential due to what? 100 divided by 3, correct? That is what? 100. Charge is 100 divided by 3 into 10 to the power of minus 9 divided by distance is how much? The distance is, now clearly the side is given as 2 centimeter. 2 centimeter. So the diagonal, half of the diagonal is how much? That is what? AO, that must be is equal to side 2 centimeter divided by root 2. Correct? So that is what? 2 by root 2 is nothing but how much it is? How much? Can you please tell me? It is what? Root 2 centimeter, right? Root 2 centimeter. That's the reason why it is root 2 into 10 to the power of minus 2 minus 100 divided by 3. The potential at A is 100 by 3 into 10 to the power of minus 9 divided by, this is also how much? Root 2 into 10 to the power of minus 2 into the charge mode is how much? Minus 10 divided by 3 into 10 to the power of minus 9. Okay, so therefore for that what we'll get here? So this is what going to be 0. So that's the reason why the work done is going to be 0 here, because this line itself is an equipotential surface. These 2 points are nothing but the equipotential points. So that's the reason why we're getting the work done is how much is going to be 0. So this is how we can calculate. Please try to remember this concept. This is very much important. Thank you very much for watching this video. Wish you all the best for your examinations.